Hello. Welcome to another online lesson. Mr. Cohen here. This one is equivalent expressions with algebra. Before we get started, there are some key terms we have to get down. First one is a term. When addition or subtraction separate an algebraic expression into parts. Now, I have a big long problem right here, and I'm going to show you what term means, but as I show you, make sure, pause the video, get the definition down. So what we're looking for is addition or subtraction. They're going to be like stop signs to represent what a term is. Here is 16 divided by 8. Boom. There's my first term. I knew that to stop when addition or subtraction, that separates what a term is. So here is 16 divided by 8. There's one term. 2 times 3. There's another term. I knew to stop because there's subtraction. 6 times x, there's another term. 2 all by itself, that's another term. And 5 all by itself, that's another term. So in total there is 1, 2, 3, 4, 5 terms here. The next vocabulary word we have to know is a fancy word called coefficient. What a coefficient is a number that is multiplied by a variable. In this case, 15 times x plus 18. The coefficient here is 15. Why? Because it's the number that's being multiplied by the variable. The coefficient 15 is multiplying by the variable x. There's one more definition we have to get down. It is like terms. Now, like terms. Terms that contain the same variables. And down here I included some like terms. 2x, 5x, x. Those are all like terms because they all include the variable x. Another 57x. That's a like term because it includes the variable x. Now, 9y, that is not a like term. Why? Because x are the like terms. Oh, sorry, I lied. There was one more vocabulary word we have to get down. Equivalent expressions. Expressions that have the same value. We're looking for that equal sign. So whenever you put an equal sign, whatever's on this side of the equal sign has to have the same value of whatever's on this side of the equal sign. So here I have 3 plus 3 equals 6, right? 3 plus 3 equals 6. 3 and 3 together has the same value as 6. And here I have x plus x plus x. That equals 3 times x. X, x, x. Now, how do I know that it equals? I could pick any number in the world, any random number, and substitute it for x. For example, what if I said x equals 2? X equals 2. So it would be 2 plus 2 plus 2. 2 plus 2 is 4, plus 2 is 6, equals, if x equals 2, it would be 3 times 2 is 6. Boom. You can pick any number, substitute it for x. If it equals on both sides of the equal sign, that is what's called an equivalent expression. Now, we're going to use all those vocabulary. Here, I have a task. 2 different expressions that I'm going to ask us to simplify. 4 times 6x. First thing you want to do is look in the parentheses. Really, that's the equivalent expression for that is 4 times, in parentheses, 6 times x, right? Again, I just expanded a little bit. 6 times x is what's there. Perfect. Now, we could do our distributive property. But first, let's look at another property called the associative property, which basically says I could move these parentheses anywhere. So let's move the parentheses to 4 times 6 times x. And let's put our parentheses here. Again, if we're dealing with multiplication only, or addition, you can use the associative property, which says that if there's 3 terms, you can put parentheses around any of the 2 terms, and you get the same answer. In this case, 4 times 6 is 24 times x, which you could just write as 24x. Boom. Let's look at this one over here. 2x plus 3x. Now, you'll notice that there are like terms, that they both have to deal with x. And let's come up with an equivalent expression for this. What if I have, sometimes it's easier if I draw a picture. So 2x, if I do 2 x's plus 3 more x's to 3. What you're probably looking at is saying, wow, that's pretty easy. It's just 2 x's plus 3 x's, 1, 2, 3, 4, 5 x's. And that's exactly it. We just combined like terms to find an equivalent. So the equivalent to that is 5x. Now, many of you are probably noticing, wow, that's just 2 plus 3 to get 5. Yep, but the key is they have to be like terms. Because let me show you another one. Here I have a whole bunch of numbers and variables and coefficients and all that good stuff. Let's come up with an equivalent expression for this one. 3x plus 6x plus 2y plus 7y. Wow, first thing that I want to do is I want to combine my like terms. What do I have together? Let's look at my x's. Here I have 3x, and here I have 6x. And I have 2y, so that's a totally different term. And here I have 7y, again, a totally different term. So what terms can we combine? Here I have 3x and 6x. We can combine those to be 9x. Plus, here's my y's, 2y plus 7y. That would be 9y. And now we have an equivalent expression. 9x plus 9y is the same thing as 3x plus 6x plus 2y plus 7y. Again, it's just simplified. Next, we have to factor each expression. This is one that I have a feeling you're going to be asked a lot about. There was some questions in class about greatest common factor and factor trees and all that stuff. And in the last video that I showed you, I just said, what's the largest number that can go into both? And I didn't really break down the factor tree. So where I got that from is I did the factor tree. So here I have 24x plus 18y. What our job is to look at the coefficients and figure out what's the largest number that can go into both? What's the greatest common factor? Easiest way, best way to do it is do the factor tree. Take my coefficients, 24 and 18, and do a factor tree. And you're probably going to have to remember back to the beginning of the year with factor trees. 24 is 2 times 12. And again, I'm going to circle my prime factors. And here's 12. That is 6 times 2, another prime factor. 6 is 3 times 2. My prime factors are circled. We're all good. 18, 9 times 2. 2 is a prime factor. 9 is 3 times 3, and another prime factor. So now we have our 2 factor trees done. What we have to do is look for matches. That's going to be part of our greatest common factor. I have 2 over here, and I have a 2 over here. So great, we have a match, 2. Next one is I have a 3, and I have a 3. Perfect. They're matched times 3. I have a 2, but I don't have another 2. No date, we don't need you. I have a 2, but I don't have another 2. No date, we don't need you. Over here, I have 3 that's already used. I have 3, no match over here. No date, we don't need you. So our greatest common factor is going to be 2 times 3, which is 6. Perfect. Let's slide over here. Now we know our greatest common factor is 6. So 6 is going to go on the outside. In parentheses, how many times does 6 go into 24? The answer is 4. And we're dealing with x, so it's 4x plus, how many times does 6 go into 18? The answer is 3. 3y. Boom. Notice 18, we just kept the y. The 24, we just kept the x. There's nothing more we can combine because these are not like terms. You can't combine x's and y's. That's like combining apples and bananas. You can't do it. So here we factored this expression into an equivalent expression. I gave you a few to do on your own. Try them out. Any questions you have, come to class with them. We'll see you in class.